Hello, everybody. Let's start this question, which belongs to the topic electricity. Define electrical potential difference. So, by definition, potential difference is the work done or energy used up for each coulomb of charge. It is the electrical energy transformed into other forms of energy, and this is precisely what already has been written here. And this is how we define potential difference. Moving on to part B, variation with potential difference of current I in a semiconductor diode is shown in figure 6.1. So figure 6.1 is actually VI characteristics of a diode. Use figure 6.1 to describe qualitatively the variation of the resistance of the diode, variation of the resistance, which means how is the resistance varying or changing for this particular diode as V increases from 0 to 1 volt. So as the value of V goes from 0 to 1 volt, how does this resistance of this diode change? We have to describe it qualitatively. Qualitatively means we have to describe the behavior or the change in resistance. There are two terms used in questions sometimes. One is quantitative, one is qualitative. When a question asks quantitative, that is specifically means that we have to give our answer using some numbers or some specific values. For example, quantitative explanation of resistance would mean that we give some values of resistance, but here it's qualitative, which means we can just describe using words what is happening to the resistance without using any values for the resistance, without needing to calculate it. So quickly, let's have a look at the VI characteristics, and first of all figure out how is resistance even related to VI characteristics. So by definition, resistance is a ratio between PD and current. Now, looking at this graph, it's a graph between current versus voltage. And if I try to find out the gradient of the graph, it would be gradient equals quantity plotted on the y-axis over the quantity plotted on the x-axis. Now, looking at the two equations, we can safely say that resistance is actually reciprocal of the gradient of this graph. So all we need to do is look at what is happening to the gradient of the graph, and the opposite will be true for the resistance. So starting from 0 volts, we can see that the graph is a flat horizontal line till about 0, 1, 2, 2.5 volts, which means that the gradient is zero or the resistance is really high, which is very visible because no matter what the value of PD is, the current is zero. So there is infinite or very high resistance. After 2.5 volts, we can see that the gradient of the graph has started to increase, and the graph is a bit of a curve. The gradient is not constant, it is increasing. So we can say that after 2.5 volts, the resistance starts to decrease. So now we can see as the PD increases, the current starts to increase as well. And roughly after we can say zero point 0.6 or 0.65 volts, the resistance becomes almost constant because we can see the graph is becoming a straight line, which means a line with a constant gradient. So let's quickly write it down. And here we go. From 0 volt to 2.5 volt, the resistance is very high, or we can even say infinite. And how do we know? We know this because there is zero current. After 2.5 volts, the resistance starts to decrease as current increases. After almost 0.65 volts, the resistance becomes constant. And that is our answer.